Hi everyone and welcome back to the channel. I am Shogoto, a Power BI developer, and if you have an interview coming up, you are in the perfect place. So let's be honest, preparing for tech interviews can be super stressful, right? So I did the hard work for you. I reviewed over 200 plus questions which is asked in top MNCs and I found a massive pattern. So in today's video I am sharing the top 6 questions that will pop up in almost 90% of your Power BI interviews. So whether you are a beginner or already working in data, these are absolute must-know topics. So seriously, don't go to your next Power BI interview without watching this video first. So grab a pen and let's dive straight in. So coming to the first most important question, what is the difference between import mode and direct query mode? So you should be starting your answer like, in my projects, I have worked with both import mode and direct query mode. So depending on the business requirement, okay. So what does import mode does? Import mode copies the data from the source into the Power BI's in-memory engine, which is called Vertipack, okay. Since the data is stored in in-memory, reports are extremely fast, okay. But the only limitation in import mode is that the users only see the data after the schedule refresh. So you will be able to see the latest data only after you refresh your data set, okay. But in direct query, what it does not store the data inside Power BI, okay. So whenever a user clicks on a visual, Power BI sends a SQL query to the database and it fetches the latest data. So whenever you click on a particular slicer or a particular filter, it sends a SQL query to the underlying data source in order to fetch that particular data, okay. So since every interaction hits the database, the report performance depends on the database performance. So I've already told, since every time you click on a particular visual or a particular slicer, it has to send a SQL query to the underlying data source in order to collect or retrieve the data. So the performance, it heavily depends how fast it can retrieve the data from the data source, okay. So the performance, how fast the dashboard is, or how fast the reports are working, or how fast the visuals are working, everything is depend how quickly it can retrieve the data from the underlying data source. I mean, the performance of the reports depends heavily on the database performance. You understood? Then you will be giving a hands-on example that in one of my sales projects, the sales table contained nearly around 45 million records, but the business users only needed yesterday's sales data every morning. So the refresh has to be done once every morning, okay. So you'll be saying that you used import mode because report performance was very important in this case, and refreshing was done every morning and it was sufficient, okay. So however, in another dashboard you will say that you developed a dashboard for the operations team. So they wanted to monitor the incoming orders every 2 minutes. So since they required live data, you implemented direct query so that every visual always displayed the latest information, okay. So you will be giving 2 hands-on example in order to make your answer crystal clear, okay. So then making you understand for the summary of import mode and direct query. So in import mode, data is stored inside Power BI. In direct query mode, the data stays inside database, okay. In import mode, the performance is very much fast, and in direct query mode, the performance depends on the database performance, okay. In import mode, we can do schedule refresh, and in direct query mode, we don't need to do schedule refresh. We always get real-time data, okay. In import mode, it supports full DAX. In direct query mode, it has some DAX limitations, okay. And import mode, it's based for analytics, and direct query mode, it's based for live monitoring, okay. So coming to the next question, what is the difference between calculated column and measure? So this is also one of the most important and repeatedly asked question in most of the Power BI interviews, okay. Almost 80 to 85% chance is there that this question will be asked, okay. So a calculated column is calculated row by row and it is stored inside your data model, okay. But a measure is calculated only when a visual requests it, okay. So a calculated column, it takes up actual space in your data model, and it consumes memory. Okay, but measures, what it does, it consumes less memory and therefore are preferred wherever possible. Okay, then you will give your hands-on example that suppose you have this table which is product, quantity and price, and the product has product items and quantity has the number of quantity of that product, and price is the individual price of that product. Okay, so calculated column, what it will do, it will create a new column in this table. Suppose we will create the DAX measure like total amount is equal to sales quantity into sales price. So we want to calculate the total amount for each product. So we have to multiply the price for each item into the number of quantity in order to get the total amount. So this total amount column will be created at the right side of the price, and it will be created in the original data model. Okay, so in your original data table, the column will be created as total amount column, and the values will be showing for each of the product. Okay, so the result will be like laptop, and for mouse total is equal to this amount, and for mouse will be this amount. So this value is stored permanently. So since a measure does not work on a row by row context, it gives you the aggregated value, right? So we have to make use the operator SUMX in order to calculate the total sales. Okay, so SUMX is equal to the table in which we want to operate the SUMX operation in, that is the sales table, and we will be implementing a expression. So what is the expression? The expression is sales of quantity into sales of price. So after evaluating this expression, sales of quantity into sales of price, then it will do the sum of this in order to get the total amount. Okay, so the total sales is equal to SUMX sales in which we are operating the SUMX function in, and the expression after which we will do the sum operation. Okay, so this is the expression that will be calculated first, and after that the sum will be done of this expression. Okay, so if you place this measure that you have created, that is total sales, in a card visual, you will get the aggregated total amount, means the summation of the amount of laptop, mouse and keyboard. Okay, because it gives you the aggregated value. A measure gives you a aggregated value. But if you want to visualize it in a row by row basis, you can also do that. You can put that measure in a table visual along with the product column. Okay, so it will, the measure will return the amount for each product in a table visual. Okay, so you will give a real project example, as in one of your dashboards you had around 20 million transaction records, and initially another developer had created more than 40 calculated columns, and obviously as a result of which the PBIX size has increased significantly. Okay, so what you did, you converted most of these calculated columns into measures that were only required in the visuals. Okay, so this reduced the model size and increased your report performance. So coming to the next question, so it is one of the most frequently asked DAX interview questions, that is, give the difference between sum and SUMX. Okay, the easiest way to remember it is that sum simply adds the values of an existing column. Okay, whereas SUMX first performs a calculation for each row and then it adds the results together. Okay, so we will understand with the help of a sample data set. So consider this table which consists of product column, quantity column and price column. So we will use sum to calculate the total quantity. So total quantity is equal to sum of sales of quantity. Okay, so sum can only add the values of a single numeric column. It cannot perform any row level calculations. Okay, so in this example it simply adds all the quantities together. Okay, so the calculation is 2 plus 5 plus 3 is equal to 10. So the total quantity is equal to 10. Okay, so in case of SUMX, so we'll understand the syntax. So SUMX, for SUMX total sales we are calculating is equal to SUMX sales, that is the table on which we are performing the SUMX iteration, comma sales of quantity into sales of price. Okay, so SUMX is an iterator function, so it goes through the table row by row and it performs the calculation that we specify for each row and finally adds all those calculated values together. So we need to specify an expression that will be calculated first before doing the addition. Okay, so here the expression is sales of quantity into sales of price. So after evaluating this expression for each row, then only it will do the summation of this expression. Okay, so it will calculate each row, that is for laptop it will do quantity into price, that is 50,000 into 2, that is 1 lakh. So it will give the total sales as 1 lakh. Okay, so similarly for mouse it will calculate 800 into 5, so it will give 4,000, that is for total sales it gives 4,000 for mouse. Similarly for keyboard it will do the multiplication 3 into 1500 and will give the total sales as 4,500 for keyboard. So then after doing the expression, that is quantity into price, it will add this column. Okay, so add all the results, that is 1 lakh plus 4,000 plus 4,500. So it will give this as the final result for total sales. Okay, so this is how the SumX operation works. Okay, so we'll give a short summary for sum and SumX. So for sum, remember it adds an existing column, whereas SumX it calculates each row first and then it does the addition. Okay, for sum it doesn't iterate, for SumX it iterates row by row. So sum is faster, whereas SumX is slightly slower due to row by row calculation. Okay, so sum use when the values already exist, and we need to use SumX when a calculation is needed before doing the summation. Okay, so coming to the next question, what are the different schema you know and which one you have used in your data modeling? So there are two types of schema, star schema and snowflake schema. So in star schema there is one fact table and there are multiple dimension tables. Okay, and each dimension table is connected to the fact table by a one-to-one or one-to-many relationship. So in this small diagram, if you consider this sales table as the fact table, and the product table, the date table, the region table and the customer table are the dimension tables. Okay, so the dimension tables are connected to the fact table, that is the sales, by a one-to-one or one-to-many relationship. Okay, so coming to snowflake schema, there is one fact table and there are multiple dimension tables which are connected to the fact table, but each of the dimension table is further normalized to exactly two more dimension tables. Okay, so we will understand with the help of this diagram. So consider the sales table as the fact table which is located in the center. Okay, the customer table, the product table, the date table and the region table are the dimension tables. Okay, so these four are the dimension tables. So you will notice that each of the dimension table is further connected to two more dimension tables. Okay, so the date table is normalized into year table and month table. Okay, so the region table is normalized into country and state. Okay, so the customer table is normalized into customer segment and customer type. Similarly, the product table is normalized into product category and product brand. Okay, so you will say like in almost all your projects you have used star schema because it is easier to understand and it is less complex. Okay, so giving a small summary between star schema and snowflake schema difference. So star schema there are denormalized dimensions. Okay, but in snowflake schema there are normalized dimensions. Okay, in star schema the query performance is fast. Okay, but in snowflake schema the query performance is slow due to joins. Okay, star schema it is less complex, snowflake schema are more complex. Okay, so in star schema there is a high data redundancy, but in snowflake schema there is a lower data redundancy. Okay, and star schema it's easier to understand and snowflake schema it's better for complex relationships. Okay, so coming to the next question, what is RLS and what are its types? So row level security is a security feature in Power BI that restricts the data visibility based on the logged in users permissions. Okay, so it ensures that different users can see only the rows that they are authorized to access while using the same report. Okay, so there are two types of RLS. static RLS and dynamic RLS. Okay, so we'll explain static RLS with the help of an example. So you will say, like, in one of your sales reporting projects, you had separate regional managers for India, Germany and USA. Okay, so each manager should see only the sales data of their own country. Okay, suppose the sales table consisted of order ID, country and sales. Okay, so in step 1 you will create 3 roles for 3 different managers. Okay, so you will create roles like India manager, Germany manager and USA manager. Okay, then in step 2 you will apply DAX filters separately for 3 different roles. So for India role you will restrict the country is equal to India. Okay, so for Germany role you will restrict the country is equal to Germany. Okay, and for USA role you will restrict country is equal to USA, and then you will publish the dashboard to Power BI service. Okay, so in Power BI service you will be assigning each of the manager with their respective roles. Okay, so in Power BI service we need to assign each of the managers email ID with their respective roles. Suppose the India manager, we need to assign the role as India manager that we have created in the first step, India manager, right? So for the manager of Germany we need to assign him the Germany manager role that we have created. For similarly for the USA manager we need to assign him the USA manager role. Okay, so you will tell, like, you have used static RLS because there were only 3 countries and the users were rarely changed. Okay, so managing a few roles was simple and it required minimal maintenance. Okay, so you will explain dynamic RLS with the help of another project example. So you will say, like, you had more than 300 sales managers across different countries. Okay, and creating 300 static roles would have been very difficult to maintain, so we had to implement dynamic row level security. Okay, so the sales table consisted of country and sales. Okay, then we need to create a mapping table which will contain the email IDs of the managers and their respective countries. Okay, then we need to create a relationship between this user mapping country column with the sales country column. Okay, we'll create a relationship and then we'll create a dynamic RLS filter. So on the user mapping table we'll create a DAX measure like email ID is equal to user principal name. Okay, so what does it does? Suppose the logged in user is india.manager@company.com. So the India manager has logged in. Okay, so Power BI, what it does, it automatically it returns the india.manager@company.com with the help of this user principal name. So the user principal name DAX function, it captures the logged in user's email ID and it returns that email ID. So in this case we have taken the example of the India manager. Okay, so it finds that the email ID in the mapping table. Okay, so the logged in user's email ID, it matches with the email ID in the mapping table. Okay, the mapping table shows that the country is India. Okay, and through the relationship the sales table is filtered to only India. Okay, so in the original sales table, so the user who has logged in is the India manager, so he will be able to see only the sales for that particular country, that is India, in the original sales table. Okay, so whenever he logs in he will be able to see only the sales data in the dashboard. Okay, so coming to the next question is on performance optimization in Power BI. So it is asked in almost 90% of the Power BI interviews and it is the most important question. Okay, so performance optimization means making Power BI reports load faster and refresh faster so that it can provide a better overall experience to the users. Okay, so we can optimize the Power BI reports at 4 levels: data level, model level, DAX level and visual level. Okay, so in data level what we can do, we can load only the required data. So never load unnecessary data. If the business needs only last 2 years of data, only load those 2 years of data instead of the entire database. Okay, so less data means faster report performance. So we can write a SQL query at the source database itself, that is select star from sales where order date is greater than equal to date at comma year comma -2 comma get date. So what this query is doing, so this query is helping you to restrict the order date for the last 2 years starting from today. So get date is used to get you the current date. Okay, so starting from current date, it will only fetch you those ordered dates starting from today for the last 2 years. Okay, and you are selecting the data for the last 2 years. Okay, so the next step that you can do is apply filters at the source level. So always filter the data in SQL instead of importing everything into Power BI. So databases are optimized for filtering. So this reduces the amount of data that is being loaded. Okay, the next thing that you can do is aggregate the data before loading. So if the report only needs monthly sales, then calculate the monthly totals in SQL instead of loading every transaction. Okay, so this reduces the number of records and also improves the overall performance. So you can write a SQL query in order to group the sales by month. Okay, instead of loading every transaction, you can group by month and then you can load the sales and the month. Okay, so in the model level, what you can do, you can use import mode. So wherever possible, try to use import mode because the data is stored in Power BI's memory, making the reports very much faster than direct query. Okay, then what we can do, we can follow a star schema. So use a star schema with one fact table connected to multiple dimension tables, and simpler relationships help Power BI to execute queries faster. Okay, so then we can use proper data types in the model level. So always assign the correct data types. For example, store numbers as whole number instead of text. So this reduces memory usage and also improves the performance. Okay, so third, in the DAX level, what we can do, we can use measures instead of calculated columns. Okay, so measures are calculated only when needed. So whereas calculated columns are stored in the memory itself. So using more measures helps to reduce the model size. Okay, and we can use variables. So use variables while writing DAX measures. Okay, they improve the readability and they avoid repeated calculations and make the code easier to maintain. Okay, then what we can do, we can use DAX Studio. So DAX Studio helps identify slow running DAX measures so that you can optimize them and improve the report performance. Okay, so in visual level, what we can do, we can limit the number of visuals. So every visual on a report page runs its own query. Okay, so if there are many visuals, Power BI has to execute many queries at the same time, which slows down the overall report. Okay, so keeping fewer visuals on a page improves the report performance and the user experience. Okay, so at last, giving a small summary, to optimize a Power BI report, you need to reduce the unnecessary data, build a efficient data model, write optimized DAX measures, and avoid overcrowding report pages with too many visuals. Following these practices will definitely result in faster and efficient reports. Okay, so that's it for now. The top 6 Power BI interview questions. I took the time to explain each one of them in detail because they are truly that much important. Okay, so understanding the clear details behind these concepts is exactly what will help you to stand out and clear your interview. Okay, so if this video helped you, please hit the like button and subscribe to the channel and let me know in the comments. Okay, so best of luck with your preparation. I will see you back in another video.